Hi everybody, Jeff Simon here for SocialFlight, and today we're going to talk about alternators and specifically about gear-driven alternators for Continental engines. Now, if you have one of this style of alternator on your aircraft, let's say you fly a Cirrus or a Bonanza or pretty much anything that's got a gear-driven Continental alternator on it, well, you need to watch this video because there's some very, very important things that I'm going to explain to you that could not only help save your wallet and help protect the aircraft, the maintenance of your aircraft, but also may end up saving your life because a gear-driven alternator is something that is actually a really fascinating, eloquent design that works extremely well. But if it's not maintained properly, then the fact that that alternator is directly attached to the engine means that this is one of the rare cases where an electrical failure in an aircraft can actually impact the engine's ability to make power. And that means it could be the difference between a safe flight and making an emergency landing. Now, the way that a gear-driven alternator works on this, and I'm gonna use this, which I'm installing on our Bonanza shortly. This is a Hartzell Engine Technologies plain power C14100 alternator. This is really a beautiful alternator and a work of art, and I say that very seriously because usually you don't think of things like alternators as being so exciting, but this particular alternator is amazing because it can put out 100 amps of power at very low RPM, and it does that in an incredibly smooth way because this is a 6-phase alternator. Go look that up separately. That'll help tell you a little bit about why it is so smooth and able to provide so much power so reliably. It does it with a hairpin stator. It's a really, really solid design. And with all of the technology being added to aircraft panels these days with new avionics and LED lighting that comes on and off with bursts and so many other things, having a really good alternator that can provide solid power like that is incredibly important. So, I'm going to be installing this on the Bonanza. But here's what we're going to talk about today that's so important. The way that one of these gear-driven alternators works, it is mounted directly to the engine case. And you can see in this design that what it means is that this part of the alternator, as it's mounted there, has to mesh with a gear. And this design shows you that it actually works and connects directly to a gear on the crankshaft of the engine. This ring gear actually is what engages there. Now, as you can imagine, if we're going and attaching an accessory directly to a gear hard mounted to the crankshaft of the engine, then it's very important that we protect the engine first because accessories are less expensive to replace than an engine, and we want to do everything we can to keep an accessory issue that could arise from putting the engine at risk. And so the way that that's done is with this device right here. This is called an alternator coupling. And as you can see, it's got some pieces to it there. You can see this orange material. You can see there's several different layers here radiating out of material. And the purpose of this coupling, I think, is quite misunderstood by a few people. This serves multiple purposes. One of the purposes that this serves, of course, which we were alluding to earlier, is that should the alternator seize for some reason, should it stop going, well, this gear that is in here can continue to spin because of this elastomeric material that you see in orange right there. So in itself, it is serving a feature that is sort of like a function, that is basically like a clutch, where this can essentially break away and keep spinning attached to the engine, while the alternator, which is attached to the hub here, the outside of this, is locked in place, should that happen. Now, that's an extremely rare thing to happen, and so it's a safety that's built in there in case of something like that. But what's lesser understood by, I think, a lot of mechanics and certainly a lot of owners out there is the additional function that this alternator coupling performs. Now, when you think about an engine running, it has power pulses. It has a certain amount of vibration that occurs and power pulses that occur based on the number of cylinders in the engine and things like that. And then that in itself, you don't want to be brought directly to the alternator through that direct gear drive. In a belt-driven alternator, it's dampened by the belt itself, so that's not really an issue. But in a gear one, we want to dampen it. Now, in addition to that, we have some pulses and power that come from the alternator. An alternator is a device which takes mechanical power and turns it into electrical power. And by the fact that you are drawing different loads as you flip on the gear and have this big load that's drawn in order to put the gear down or turn on whatever you're going to turn on, every time that you demand more electricity from an alternator, you are actually putting a mechanical load on the alternator itself. And we also want to dampen that from getting directly through to the crankshaft. So we want this idea of some give to take place. And that's the other function that the alternator coupling actually does. Again, if you look here at the inner gear and then the elastometric material and the outer cup that is on that, this in use is always moving. So it flexes a little bit in counterclockwise and clockwise precession, that allows it to absorb some of those power pulses and sort of isolate the alternator and the crank from one another with those subtle movements. And the key to making this a safe unit that works as designed, because it's a very eloquent design, is that it is really two things. Number one, that it's installed properly so that it can actually move the way it is designed to move and yet not move more than designed to move or get loose in some fashion that would cause fatigue and cause it to somehow come apart. So that's one, is proper installation. And then the second part of this is proper maintenance. And this is one of the most overlooked aspects of alternators and alternator couplings that are out in the field today. Because according to Continental in their M0 maintenance manual, this has to be checked anytime that the alternator comes off, anytime that, and on some regular basis based on the number of hours dictated by Continental, to make sure that this is functioning properly. They actually you actually want to look at how it's installed and then check its slippage. Remember we mentioned that clutch function earlier. It's very important that we know exactly what that slippage is supposed to be. And Continental spells this out in the M0 manual and actually says that for couplings that are brand new, 180 inch-pounds, it should not turn when you pull it through a 45-degree arc. It should be above 180 inch-pounds. And then if it's been in service for more than 25 hours, that number drops to 140 inch-pounds. And so you need to be able to test it. So install it properly and test it regularly. And that's your key to making sure it works. Now, before we get to doing the installation and showing maintenance, I want you to see what goes in to actually making this. Because when you look closely at this, it almost looks as if that elastometric material has been poured and cured in place. And that's what I actually thought how these were produced for quite a long time. Until I spoke with the experts at Hartzell, and they showed me how they actually go and work on these, because they actually produce some of these and do rebuilds on them, etc. And it's quite fascinating. And so it all starts with this. This is the cup that you saw of this is a disassembled one prior to manufacturing. This is the outer part of this finished product that you see there. And so it has the outer cup, and then it has what is essentially a support tower at the top. Okay, so we understand that. The next piece is this. Instead of actually being poured in, this is what is the elastometric material, is basically a donut that has a metallic ring in the center, and then we have the gear itself. And the gear itself is made up of a couple parts. It's one part of this hardened gear that you can see, but in the center of it is a bearing material. And you can actually see that right there. And so I can't actually, I don't have the tools to press this in, but if you kind of look at this as a stack up before it's all assembled, you can see that's how this right here turns into this finished product. And that bearing material that you see here in this design, that is what allows that rotation to happen. And the key to making that work when you install this on the shaft of the alternator is this thing right here. This is a bimetallic washer. It's a thrust washer. One side of it is steel, as you can see here, and the other side of it is a copper color, but is actually a bearing material surface. It's a surface that is designed just like solid bearings that are inside the engine and bushings and things like that. It's actually designed to allow it to move properly. Well, the key to making that happen is to make sure that it's installed the right way. And one of the biggest mistakes that happens in the field is people do not understand that this is a bimetallic washer, and the copper side of this washer has to face the face of this. When you see this material and then you put the copper towards it, that allows that twisting motion to happen in service so that it can actually flex in the way it's designed. The next part of making all of that work is that it has to be properly torqued. As you can imagine, anything with bearings and bushings have to have exactly the right amount of preload and torque on them that doesn't allow play to happen, but does allow the part to move properly. If it's too tight, it can't rotate, and it starts to dig into that bearing material and wear away that bearing material, which then leads to it being too loose, and then leads to slop, which is the same thing as it being too loose to begin with, at which point, and I have seen this in the field, at which point then this coupling will start to move on that shaft until it just breaks off and goes right into the engine, stopping the engine from working properly. Very, very dangerous situation if these are not installed properly. So I'm going to take you through this right now. Again, we're just going to take the nut off of this, and I'm going to kind of show you how this all stacks up. We're taking off, this is just a toss away cardboard spacer. And let's take a look here. As you can see here, this is the shaft. And this is true of all of these gear-driven alternators. And there's a keyed part right there on this shaft. And the way that the shaft is actually milled, all you need to do is take this and again, follow the M0 manual. This is not meant to be detailed instructions on it, but just showing you basically how it works so that you can follow it. But this coupling goes on and slides on, as you can see there. I've just put it in, keyed, and just pushed it down just by my hand, nothing much. And then the next thing is, as we mentioned, that bimetallic thrust washer. And that thrust washer needs to go on and face in that proper direction. So I'm going to put it on here. You're going to see the steel surface of the thrust washer facing out, so you don't see copper. Just like that. This goes in this way. And then we have this nut, which comes, you should always use a new nut. If you have a new alternator, always use a new thrust washer, always. Remember, it's a bearing surface, it gets worn away, always use a new thrust washer. And then we're just going to tighten that down on the shaft, and then you have the ability of setting it to the torque limits. Now again, go by the M0 manual. There's Appendix B, which has all of your torque settings on it. I did check it, of course. It happens to be 300 inch-pounds in this case for this particular one that actually gets tightened down. And then it says tighten down to 300 inch-pounds. If it does not line up for a cotter pin to go in, then you can continue to tighten it up to a maximum of 450 inch-pounds until you get to where you need to for the cotter pin to line up. Now, the last step in this process is the cotter pin, this special cotter pin that we have right here. And what's so important about this cotter pin is that it has to be set up exactly right so it is not interfering with the engine and not interfering with the rotation, as we talked about, for this alternator coupling. And what that means is that after you've put it in, after you've torqued it properly, lined it up and put it in, they give you specific instructions that the part of the cotter pin that bends forward into the engine, essentially, needs to be trimmed in such a way that it cannot extend past the end of the shaft, the drive shaft of the alternator. That way it can't actually hit that ring gear inside the engine. And then the other part of the cotter pin that you bend down, that essentially is bent down towards this thrust washer right here, can't touch the thrust washer. Because as you can imagine, if the cotter pin were bent down and jammed against the thrust washer, well then you're affecting that rotation. So it's very important that the cotter pin be put in properly. So the stack up is right, has to be just right, the torque has to be just right, and the cotter pin has to be installed just right. And the last part of this is not just about installation, but it's also about testing. And that has to do with the tools that you use in order to do this. The only tools that I'm aware of that are on the market right now are ones that we made in order to make it easier for people and safer for people to do this in the field. You can find this at approachaviation.com, just www.approachaviation.com, and at most resellers that sell parts and tools like this. But it's made up of two parts. The first, that's a part of all this, is actually this spanner right here, as you can see. And it has these two notches there. Well, if you look, this is a different coupling. If you look at the coupling, you can see it has notches 180 degrees apart. And the purpose of the spanner is that it fits in those notches. Well, that holds the bottom, that holds the base and the cup for the coupling. And then what we have is this, which is a special socket that can't hurt the actual gear because it's made out of aluminum in its gear point that meshes on it. And that goes on top and fits in place just like this, and then just has a 3/8 ratcheting socket hold in there. And then you can put a torque wrench on it and pull it through to actually test that movement so that you can actually see it rotate at the right time. So again, you can find that tool at approachaviation.com or from many different retailers. Just look for alternator coupling tool. That's really what you want to look for. And that will help you make all of that happen. Now, the last step as we go and we start doing this torquing, I will say there's something really wonderful I do like about, when you have a modern design like this plain power alternator. One of the nice things is that when it's time to go and actually torque down that nut, it has this cool thing. You can imagine torquing that nut would be very difficult because how do you hold the shaft? Well, you can certainly hold the outside of the coupling itself using that spanner that we talked about, and that's very helpful. But if you have one of these alternators, in addition to that, the center of the shaft actually accepts an Allen wrench. And that allows you to actually be holding the shaft itself instead of the coupling and then using the key as what's holding the rest of it in place as you torque that down. So you can do that if you use like a crow's foot on a torque wrench or something like that. Or if you want to use a socket, then again, just use the Approach Aviation spanner that comes in the kit and use that, and you get everything all torqued down and installed. So that is how this is done in terms of maintenance and in terms of inspection. And I just want to encourage everyone out there, please, 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 if you fly behind a geared alternator on your aircraft, make sure that A, it's been installed correctly, and B, that you're actually checking it on a regular basis. Because when these things in service, you want to make sure that none of the elastometric material is starting to come out. These wear over time. You do not want a very, very old one of these on your aircraft, because when you think about it, again, your alternator is directly connected to the crankshaft of your engine. An alternator failure in a geared alternator engine is an emergency. You make an emergency landing right away. You do not continue with an alternator failure in one of these aircraft. And I cannot emphasize this enough. It doesn't matter to me if people have backup alternators or things like that. It's not about the electrical power. It's about the fact that when your alternator light comes on, you do not know what has failed. And if for some reason it is a mechanical failure, if something's happening to the shaft of the alternator, to the coupling itself, anything else, you need to get on the ground quickly because you don't want the alternator coupling to start shedding material into your engine. You don't want, if there has been some type of a mistake in how it was assembled, this starting to come apart and then get in your engine and destroy your engine. You want to treat it the right way. Get on the ground, get safe, verify it later. Just something really, really important for you to know. And I want to keep as many people out there as safe as possible because I'll tell you, I have seen these in the field. My son Jake has also seen these in the field where they've been installed incorrectly, and within 100 hours, you're dealing with an emergency with the aircraft. So it's very important to do that. And also, again, if you have, just don't let them get old in the field without having been inspected. The last thing is that this is a relatively new design to have the elastometric material in this design of the coupling. And there's an older design that essentially uses a metal spring. That should be out of service. If you find that on your aircraft, toss it away, get the new alternator coupling for there. That is an old design that's really, really not safe to keep in service. And so I just want to help protect your wallet as well as your life. And hopefully this is something that's shed a little light on this, showing you how these are all made. And thanks again to Hartzell Engine Technologies for everything that they do to support General Aviation, for making these really cool alternators, for making couplings available, for refurbishing couplings, for educating people, and for giving me some of the tools that I need in a disassembled version here to show you how this all works. For SocialFlight, I'm Jeff Simon. Be sure to check out SocialFlight.com and the free mobile apps for Apple and Android devices. We have tens of thousands of aviation events and destinations, so many cool places to fly and experience what's out there. We have FAA courses for wings credit, for AMP renewals, and your IA renewals as well. All of it is in SocialFlight, and we have our Fly to Win challenge as well, where we give away tons of prizes. And so with that, again, thank you so much for watching. I wish you all blue skies.